Solving this question, x raised to the power of x equals to 11, and we have to find what the value of x is going to be. Let it be observed that you can't apply natural log at the beginning to both sides of the equation because it's not going to lead to any important place or point, because at the end of the day, the x value that we're looking for is still going to be at both sides of the equation, and when it is, it means we are not heading to anywhere. Looking for x and it's at both sides of the equation. This means this is a wrong way of approaching this. Even before we approach this in a proper way, there is something we must do first. So let's first of all guess what the value of x is likely to be. So let's assume x equals to 1. If that is the case, it means we are talking about 1 raised to the power of 1. 1 raised to the power of 1. And everybody knows that this is not equal to 11, because 1 raised to the power of 1 is same thing as 1. So if we say x equals to 2? Okay, we are saying 2 raised to the power of 2. Okay, 2 raised to the power of 2. It is clear that it's not going to be equal to 11, so which shows that x can never be 2, because 2 raised to the power of 2 is same thing as 4. So it is clear that x can never be 2 and it can be 1. So let's assume x equals to 3. Can x be equal to 3? If it is, that is, we're saying 3 raised to the power of 3. And if we have 3 raised to the power of 3, can it be equal to 11? It is clear that it is not also equal to 11, because 3 raised to the power of 3, we are talking about 27. So whatever the value of x is going to be, it can never be 3. But one thing we have to observe is that 11, this 11 is in between 4 and 27. 11 is in between 4 and 27. So which shows that the value of x that we're going to get accurately is going to be in between 2 and 3. So we can conclude that at the end of the day, x is going to be, that is, between 2, but we don't have the accurate stuff, between 2 and 3. That is what the value of x is going to be at the end of the day. So to go further, we write our question: x raised to the power of x equals to 11. So the first thing we're going to do is to apply natural log to both sides of the equations. So we have ln x raised to the power of x equals to ln 11. So we're going to apply this logarithm rule to the left hand side of the equation. That is, when we have ln a raised by the power of m, of course this is going to be m ln a. So if we do, we now have x ln x equals to ln 11. If we look critically, there's no way we can cancel this ln x and say x is equal to so and so. So what we're going to do here is to apply what we call Lambert W function. So what the Lambert W function is saying is that when we have a mathematical format of this nature, m exponential m, and if we have this format and we apply Lambert W function to this format, that is W, which stands for W function, Lambert W function, the result is going to be m. So if that is the case, we're going to rewrite this x in terms of this m exponential m format. Therefore, in order to transform my x to this format, I'm going to need a certain logarithm identity to do that. What the logarithm rule says is that when I have exponential ln m, this is going to result into m. That is, whenever I ended up into this format, the end result is m. Since the left hand side is also equal to the right hand side, and the right hand side is also equal to the left hand side. So when I have m, I can rewrite it in form of the left hand side. Therefore, I am transforming from right to left. Therefore, if I rewrite my x with this logarithm identity, so my x can be transformed into exponential x ln x. That is, exponential ln x is going to give me x. Therefore, I'm going to rewrite my x to conform with this left hand side. So instead of writing x here, I'm not going to write x here again. I'm going to write exponential ln x. Why am I doing all this? Is because I need to apply Lambert W function to this left hand side of my equation, and in order to do that, I must reform whatever that is here to match with what my Lambert W function will be able to perform on. Since we've established this to be x, exponential ln x, then we can now have exponential ln x, then multiply by ln x equal to ln 11 as it is. Since we have the format that we want, then we can now apply the Lambert W function as established earlier on. We're going to apply this Lambert W function to both sides of the equation. Therefore, by applying Lambert W function to both sides, we're going to have W, put in brackets, exponential ln x multiplied by ln x, then equals to W function to right hand side, that is ln 11. So if we like, we can rewrite this since there is multiplication in between the variables here. So we say W function. So I'm writing ln x first, ln x first, then multiply by exponential ln x. So equals to W function ln 11. Therefore, we can see that we can perform W function on this left hand side because it's already conformed with the identity that was shown earlier on. That is, if we have m, exponential m, the result is going to be m when W function is applied. But in our case here, we have ln x, exponential ln x. So wherever that is here, it's also the same thing that is here. And that is definitely the result of applying the Lambert W function. So we're going to have ln x at left hand side. So we still have W function into ln 11 to right hand side. At this point, we need x at the left hand side so that x can be equal to something. We don't need this natural log. So the next thing we're going to do is to cancel this natural log. If we can do, then x is going to give us a direct value. So what are we going to do to cancel this natural log? We're going to need some logarithm identity. Remember that when we have m log into x base m, if you remember, this is going to result into x. The result of this is x because these are going to go away. So the same thing when we have exponents ln x, the result is going to be x. It's a logarithm identity. Therefore, what we actually need is this. So what are we saying is that we're going to apply exponents to both sides of the equation. Therefore, if we do, we're going to have exponential of ln x equals to whatever we do to the left hand side, we're going to do the same thing to the right hand side. So we have exponential of W function of ln 11. As explained earlier on, so this is going to go our way. Then we're going to have x equals to exponential of W function of ln 11. Therefore, in order to break this further, we're going to find what W function of ln 11 is going to be. So calculator is going to help this out. W function of ln 11 is 0.9383. Now we have x equals to exponential of 0.9383. At the end of the day, by punching the calculator to find the exponential of 0.9383, we're going to get 2.5556. This is the final answer. We might need to verify if this answer is correct for the value of x, that is 2.5556. Yes, what we're going to need to do is to insert that value into the position of x and see if it's going to be equal to 11. So we can do that. Now to do this, we're going to say, okay, this is x and x is equal to 2.55656. So we write that 2.5556, then raised to the power of x, so it's going to be raised to the power of the same thing, 2.5556. Is this going to be equal to 11? It's calculator that is going to help this out. At the end of the day, by punching my calculator, this gives me 11, and this 11 is also equal to 11 here. So the left hand side is equal to the right hand side. That shows that this value for x is perfectly correct. And also remember, at the beginning, we established that whatever the value of x that we're going to get is going to be between 2 and 3. And what we got, 2.5556, is exactly as it was established earlier. That is between 2 and 3, which is 2.5556.